graph each equation of the system, then solve the system. So the first one here is x squared plus y squared equals 8. So again, that's a circle. That's of the form x squared plus y squared equals r squared. So my r is actually the square root of 8, and the square root of 8 is approximately 2.82. So there's my radius. So now I'm just going to graph this. That's almost 3. So if you look at 2.82, that's going to be about out to here. So now I'm just going to create that circle. There it is. Okay, so now I'm going to graph the other equation. Now this one I'm going to have to change the form of a little bit. So this one I'm going to write as y equals 4 over x. And I can divide by x here because x can't be 0, because 0 times any other number can never equal 4. So that's what makes this okay to do here. Now in general, I wouldn't divide by a variable ever, but for that reason I can here. So anyways, I'm just looking at this equation here, and all I'm going to do is graph a few points to get an idea of what this thing looks like here. So now if I plug in a 0 here, that's undefined, right? But as I get close to 0, what's happening? So think about this. Let me put the number 1/10 in for x. So if I plug in 1/10 for x, I get 4 over 1/10. And you remember, when I'm dividing with a fraction here, I have to take the 4 over 1 and I flip it and multiply. So I get 10 over 1, which is 40. So then let me pick 1/100th on the bottom now. So that's going to give me 400. And then let me put 1 over 1,000, which means I'm getting closer to 0. So it's going towards infinity as I get closer to 0 on the right. Okay, so that's what that's looking like on the right. Now, when I go on the left of this thing, let's see what's happening there. As x gets really large, what's going to happen there? So plug in 1,000 for x. Now, again, we'll see that this is actually going to go down towards the x-axis as I go out far enough. I mean, we've dealt with asymptotes before. So anyways, so now I'm just going to graph 2 points here. And this will kind of show me, or show you, what it really does here. So I'm just going to plug in 1 for x. And if I plug in 1 for x, I get 4 for y. And I'm also going to plug in 4 for x, and that's going to give me 1 for y. So what that gives me is it gives me this point here, and also this point here. And then if I join those together, so now when I graph this, remember, when I'm going up this side here, it is going towards infinity. And that's also going towards the x-axis on that end. So I have a vertical asymptote here, and I have a horizontal asymptote here for this one. Now when I go on the other side, I'm going to have the same situation here. So I'm going to have a point here, and I'm also going to have a point here. And it's going to do the same thing. So as I'm on the other side, it's going to go towards that axis, and then as I go out this way, it's going to go out that way. So I can either intersect at 1 point or 2, or I'm not sure with this one, the way it graphs. But we can say, hey, there's our point. Now again, this could have more than one answer, so kind of keep that in mind too. So then this would be an answer here, and then that would be an answer there. And that looks like about 2, 2. Which looks like I'm cheating. And I could have cheated on this one. And then this would be -2, -2. Which makes sense for the bottom equation right away. Now if I plug it in the top equation, now for both of those, because -2 times -2 is 4. I'm talking about this equation right here. And then +2 and +2 is 4 also. So then when I plug it in the top though, this is really going to be 4 plus 4, which is 8. So those are both going to check. I guess I cheated. I'm a cheater. But anyways, there it is. Okay, so now if I didn't know, and because this graphing situation is very difficult to actually get a correct answer, and if I was to actually show these, because honestly, to know for certain, I would have to do this algebraically, unless my graphing was perfect, which most of the time it won't be. But anyways, I'll kind of show you what that looks like. So here we go. So essentially, when you're dealing with systems of nonlinear equations, the thing we're going to do most of the time is substitution. Okay, so either way it goes, I'm going to plug one equation into the other one. If I look at the bottom one here, I have this one already solved for y. So what that means is I'm just going to take that, and wherever y is at in the top equation, I'm going to plug it in for it. I'm going to plug in 4 over x in for it. All right, so anyways, so now if I'm looking at that top equation, I have x squared plus, and I have a y there. So instead of that one, instead of that y there, I'm going to put in 4 over x squared, and that equals 8. So now what I'm going to do is I'm just going to multiply this out and try to solve this equation. So this is going to give me x squared plus 16 over x squared equals 8. So then what I'm going to do is I'm just going to multiply both sides by x squared. So then I'm going to get x to the 4th plus 16 equals 8x squared. So now I'm going to move that 8x to the other side and put it in descending powers. So this is going to be x to the 4th minus 8x squared plus 16 equals 0. And I don't know if you know this or not, but there's a rule when I see this, these powers this way. So this is a 4th power, that's a 2nd power, and this is a number. What that means for me is when I see that this number here in the beginning is a 4 or whatever, and this second number here for this exponent is half of the power, and then this is a number on the end, that tells me that I can factor it like I normally factor things, or I can use the quadratic formula here when I see that pattern. So if this was like an 8, this would have to be a 4, and then that would just be a number. I could do the same thing there. I could use the quadratic formula or factor it using the trinomial method I learned. If this was even like, let's go with 12, and this would be a 6, that would work just the same. So it's kind of a nice little handy thing to notice. So now, this one right here, I'm just going to factor it, and this is going to factor into x squared minus 4 squared equals 0. Now again, no, I don't know how you factor, but look at some videos if you're not sure how to do that. So now when I look at this here, this is really x squared. I'm going to take this away for a minute. And I'm just going to look at x squared minus 4 equals 0. That's one of the factors because it's x squared minus 4 times x squared minus 4. So I'm going to take one of these and set it equal to 0. I'm going to move the 4 over so I get x squared equals positive 4. And then when I square root both sides, I'm going to get x equals plus or minus 2. So now essentially what I'm going to do from there is I can plug it into my y value. Now the one I'm going to plug it into is definitely this bottom one here because that's so much easier than any of the other ones. So I'm going to plug in a positive 2 in there. So if I take that now, that y equals, and then I have this 4 over positive 2, then my y is going to equal 2. So the ordered pair would be 2, 2. There's one of them. Okay, and then all I would do is I would plug in the negative now. So that's y equals 4 over negative 2. And then y is going to equal negative 2. So that's going to be negative 2, negative 2. So that's one way to do it algebraically, not just by this graphing method. Graphing methods is usually taught first for the simple fact you get the idea of what's going on with these two equations and what it means when we're solving a system of equations. That simply means we're looking where these graphs intersect. And to have that sort of knowledge going into this is really nice so that when you find an answer, you know exactly what that means. And also that it has to be an ordered pair and why it's an ordered pair. Okay, so there's the answer for that one. And again, all I had to do for this one was graph it. But I just wanted to show you the other way so that you know what's going on.